some problem with the internet connections. So we are stopping here, right? We are stopped here on the part 2 of the crystal structure, metals and ceramics. So for this part, actually, we are focusing on the direction indices as well as Miller indices. And the last part actually is we will explain about the linear density, planar density. So Miller indices and also direction indices is important for the calculation of the atomic density, volume density, as well as the planar density, linear density, right? Okay, and then what is the definition of polymorphism? Okay, the definition of polymorphism is important because later we will in the next chapter 8, I think, so we will discuss about the solid solutions. Okay, the solubility of the metals, the solubility of the solid metals. Okay, so that is important. Okay, so yesterday I already explained about the direction, the vectors of the that you have to consider for the calculation of the direction indices and the Miller indices. Okay, there's x, y, and z axis. So I just recall back. Y axis on the direction right. Okay, x out of the paper and z is to the top. And negative is direction to the opposite of positive. So if you look at here that atomic position are located using unit distance along the axis. Okay, so you have to see here that each atom if lie on the axis of the direction of the axis, right? So it's 100, 010. Okay, this one 011, 001, 101. Okay, so please and origin is 000. Okay, A is the length or the we call it as lattice. Okay, so vector components, if you look at here that directions, okay, we represented in the bracket without a comma. Okay, please remember if you make it another bracket with half what is it called, half circle, right? So that one is not correct. That one is for the Miller indices. Okay, so this is the red color, the arrow showing that the direction of each atom. Okay, with the on the x-axis, y-axis, and also z-axis. So let's see the procedure to find the direction indices. What I have to do is produce the direction vector until it emerges from surface of the cubic cell. Look at here that the origin is 0, 0, 0. Okay, emerge from the 0, 0, 0. So meaning that this one, the point is here. Okay, so you have to consider three direction. X meaning that is 1. Okay, y is equal to half, isn't it? Because it's just a half of the y direction. Okay, and then it's 100% for z. Okay, so meaning that 1 half and 1. So all these are positive direction. Okay, emerge from the origin. Okay, determines the coordinate of point emergence and the origins. Just now we determines, and then subtract coordinate of point of emergence by that origin. So meaning that 1 half 1 minus 0, 0, 0. So we can get 1 half 1. So since if you look at here that this is non-integer half, so you have to convert it to integer. So what you have to do is times with 2 lah. So you have to times with 2 so that you can make integer. So when you times with 2, you can get 2, 1, 2. This is the 2, 1, 2. This is the direction integer. Okay. So once you convert to integer, now you have to convert that the smallest possible integer by multiplying by an integer. Meaning that if you look at here, we multiply by 2 lah. Okay. Any the direction are negative, look at all the direction is positive. In negative, you have to put square bracket without a comma if represent the negative lah. So this one square bracket without comma. Yeah lah, without comma. Okay, so we call it as like it's like a bar. like bar line. Okay, this one is positive. Okay, so that this is the direction indices. So let's see the example. If you look at here, that is emerged from determine directions indices of the given vector below. Okay, origin tail. Okay, this is the tail. Okay, and this one is the tip, arrow tip. Okay, so it's emerged from 3 4 1 4, and the tip is 1 4 1 2 1 1 2. So what you have to do is we have to uh, subtract, okay, the coordinate of point emergence and origin. We have to subtract. Okay, so meaning that this is the emergence and this one is the origin, right, on the left side. So subtract the origins, so we can get negative half, half, 1, 1 4. And then we have to multiply with the smallest possible integer. So if you look at here, that the smallest integer we can subtract actually is a 4. Okay, because if you times with 2, meaning that this one is still half. Okay, so if you times with 2, so negative 1 1, this one is going to be negative 1 1 2. So that's why we have to multiply with 4, so we can get negative negative 2 2 and 1 lah. Okay, so we have to convert it into the square brackets, and also without the comma, if 2 2 1. Okay, so this is direction in distance. Okay, another example, if you look at here, that this is the images to the images from to the origins. Okay, so please remember this one is 110, this 110, because no z direction, right, all on the xy plane. Okay, and this one is 111 because this is 100, y also 100, z also 100 to this direction. Okay, 111. Okay, this is 210, meaning that, okay, 210 is, if you get here, that is half. Okay, because this is a half. So when you convert it into integer, okay, so 1 half 0 lah. So times with 2, so 210 lah. Okay, okay, similar also this one. And we can also define a new origin. Okay, when we define new origins, so the direction is going to be negative. Okay, this is new origin. Okay, not this is new origin. Okay, so when you define a new origin, not this one, sometimes we have to define new origin. Okay, so this is towards the opposite direction of the positive for the x and also y, because this one is already your axis. Okay, meaning that this is z, so that one, that direction is x, and that direction is y, right? Okay, so it's toward that direction. Okay, side the paper. So meaning that x, look at here, that is toward there. So meaning that this side, right? And then y also to this direction, to the left. So negative 1, 0. Okay. So if this one is origin, if you look at here, right. If you look at here, right is on the right side, which is right side. Yes, y is a positive, but to the for the x axis. Okay, because to word inside the paper, right? Okay, so we have to make it into negative. Okay, there's a question there. Ni origin kena cari atau dia, okay, generally ada dalam soalan lah, kita akan tanya. There will be in the questions. Okay, so for example, like determines what is it, later lah ada. Okay, I will show you the examples. Okay, so please find the direction indices. Please draw the, what is it, the crystal planes. Okay, or of the unit cells with the direction indices negative 1, negative 1, negative 2. Okay, so you have to define first the origin. Okay, generally we will draw the positive one. Okay, generally we will draw the positive one like this one. Okay, we have to draw positive one. Okay, so we can get the 1 1 1. Okay, if there's a negative, meaning that we have to draw again. Okay, so we have to draw a difference cube to the opposite side. Okay, to which direction? That's easy to understand how to describe. Get here that this one. Okay, okay, meaning that the origin is still here, but maybe is go to this side. Generally, for me, I will draw the positive one first. Okay, and then we can imagine towards with which direction, right? Either is y is negative or x negative, or all three axes is negative. If all three axes negative, meaning that to that side and to the bottom. Okay. 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 Determine the indices for the direction shown in the accompanying figure. If you look at here, that the projection, if we define the length is a and this one is b, right? Okay. So this one is just by ABC lah. Is defined by A, B, C. 0 is C lah. This one is Z. Okay, this one is for Y. This one is for X. Okay, become 1, half 1, 1. So generally the value is going to be 1 lah. The maximum 100 lah. 100%. Yeah? Atau, or we consider as a 1. Okay, half 1, 0. So when multiplied by 2 is going to be 1, 2, 0. Okay, this is another example. Okay, for example, if you have a question like this one, draw, what is it? 1, negative 1, 0. Right, direction within the cubic cell. Okay, so if you look at here, what you have to do is you have to draw the axis first. This is important to know the okay. Okay, so generally our cubic is will be like this lah. Our cubic will be like this, right? Like this. Our cube lah. Just call it a cube lah. Our unit cell lah. Okay. Okay. So this is the origin, right? If you look at here. This is the origin. Okay. But it said 1, negative 0, 1, negative 1, 0. Okay. So meaning that 1 is this is x, this is y, this is z lah. This is all origin. So since 100% of x, so it's going to be this one. So we will direction. Okay, 1. So meaning that towards this direction. Okay. And then y is negative, right? So y negative is going to be this direction. Okay. And then 0, right? So your point is 0. Okay, so meaning that we can guess the point is here. Point is here. Okay, because it's negative y and 0 for y. So your new cube is going to be, we can, how to say, we can move this cube and make, this is still a similar origin, right? Okay. Cube is going to be And then this one you can delete. You can delete. One you can delete. Okay. Because we draw this one, right? The okay. This direction. Yeah. Okay, one negative one. So generally for me, I suggest you draw the positive one. See where is the direction your arrow. Okay. Because generally if you draw the what is it? The positive one, the I mean the general cube first. Okay, you can imagine towards where direction of your arrow actually. Okay. So that is important. It's up to you. If you doesn't want to draw this cube first, is okay. If you have a very high imagination, okay. Kalau yang tak tahu tu susah. Okay. Betul. What the question mentioned within cubic unit cell? This one lah. This is a cubic unit cell. Okay, this is a cubic unit cell. We make in the cubic unit cell. Generally is a 111. The cube. The cube is unit cell lah within the cubic unit cell. Okay. Huh? This one I think I have now flash installer. I cannot play this one. Okay, so can you do these tutorials? Draw directions vector in unit cells for the following cube directions. Okay, 1, -1, -1, 1, -1, 0, 1, 2, 1, and 1, 1, 3. This is negative, negative lah. Okay, this one tutorial 4. Terus tutorial 4. Okay. Okay. Can you do? And then please post your answer in the Jamboard. I prepare the Jamboard. I give you the link. So please, maybe if you want to solve A, you can choose A lah. If you want to solve B, C, and D. But make sure that you have to post in the Jamboard. Okay, can you draw first on the A4 paper, and then you take picture and paste in the Jamboard. I give you the link. Wait, give you the link. Draw first. I give you the link. Mana SETK dulu. Actually, it's the same link for the Jamboard. I give you the link. Please draw first. Any number. You can choose to solve A, B, C, or D. Okay, this is the link for the Jamboard. Go to page 6. Go to page 6, okay? Let me do chapter 3, direction indices. Direction indices. Okay, go to page 6. So the title is chapter 3, direction indices. Can you do? So please post your answer in the Jamboard. Share screen. I give you 5 minutes for 9 o'clock. See. Why the color is red? Cannot see this one. This what which one? I cannot see now in the red color. Is it only me see the red color or is it not clear? See, this one A, B or C should be put A, B or C. Yes, this one is correct. A. A. So this one, the origin on top, right? Here, right? On top here, right? Okay. Actually, the also meaning that your box is if you do like this, So you can draw actually, not really by using for paper. You can draw here. So because if you look at here that -1, the question, -1, -1, right? So meaning that 1, 0, 0 minus 0, 1, 1 lah. So to the y is a negative, y is negative, z is negative, x is positive, right? So yes, towards this direction. Okay, towards this direction. So meaning that this is the new origin. Okay, because towards out of the paper, x is positive, x is equal to positive, but because we define as a new origin here, okay, we define as a new origin, so meaning that is under the this one. Okay, so this one is y, x, z. Okay, your box is towards this direction. Okay, now towards this direction. Okay, here. But it's still here lah. Okay, the origin is new origin lah, dekat on top. Okay, not usual for A lah. Okay, this is for A lah. Okay, on top. Yes, this one is the correct. How about D? Okay, let me enlarge this one. This one is okay. Is it clear? Right. You can draw directly here. Okay, it's okay. Okay, how about D? C, D. Oh, this one C. Okay, you go there. D. D where? Which one is the answer? Okay, okay. Kenapa jauh sangat daripada origin? Why like this? D. Okay, for D, D is what is it? -1, -1, 3, right? So meaning that if negative, meaning that you have to convert because D is -1, -1, 3. So meaning that this one, if you have to, if you want to make it direction indices, you have to make it integer. But when you want to make it into you want to draw, right? You have to make it the smallest number, So meaning that this one you have to divide by 3. X equal to -1 divided by 3. Y equal to -1 divided by 3. Z equal to 1 lah, right? This one, because divide by 3. All is divide by 3. Okay, so this is your position or the coordinates. Okay. Okay. Understand? So once you determine this one, the coordinate for yeah. Okay. So your position is gonna be here. I just draw the cube lah. Draw the cube. So this is the original one, right? This is the original. Yeah. Since if you look at here, -1, 3, -1. Okay, so that x to z direction just 1/3 lah, 1/3, and then y also 1/3. Okay, this one 1/3. Okay, and then z is 100% of z direction. So meaning that to that side So we can get just like this. Okay, so we choose different color because we define new origin here, so it's gonna be towards this direction. Okay, towards this direction. And one third, and 100%. So this is your origin. Okay, not this one I cannot see clearly which one is your origin. Make sure you stated by alphabet O. Okay, this is the origin. Okay, towards that. On top, what z axis 100% and one third to the y axis to x. So this is negative one, negative one. Okay, this is for define a new origin because within the cube cell. Okay, okay. How about B mana? Berterabur pula. C ya. C, let me check C. C mana ni? Tak nampak lah, I cannot see. I think this one right. Let me check. Is it your position? Okay, for C, I move this one first. I make it small. This one. Okay, for C, for C, for C, for C, C negative 1 to negative 1. So we have to convert to this one to x equal to, since we have to 2 is already more than 1, right? Okay, so you have to divide x is equal to 1, that is negative half lah. So that's your direction is negative half, 1 negative half. The maximum is 100%, 1. Okay, so if there is a 2 here, 3, you have to divide the, 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 the largest integers with the largest integers. Okay, so opposite the procedure, this is opposite side. This is if you want to identify the distance. If you want to it's like in the bracket, but if you want to so negative half, this is 1, right? Already 1, so meaning that 1 C, isn't it? So this one we can make another, because x is towards this direction, so z is in this direction. Maybe if my imagination this one reconnecting. Okay, sorry. Give half. So should be 100. Okay, and then half y direction also half. Okay. So it should be towards this direction. Nampak lah susah Okay. Saya punya jawapan half negatif half satu one half one half. So it should be the origin on the y direction. Okay, y direction. Okay, y direction pula, z direction on top. So it's towards downward lah. Okay, to that direction. Okay, this one is correct. This one is, if you look at here, z x is still positive. X is still positive. Is it down? This cube downward? I don't think so. Okay, origin you can define any position until you can get this the coordinate lah, same with the coordinate lah. Okay. Okay, I will give you the answer total for only for the C. I think is I give you in the group. Okay, you can see. Okay, only for C, that ones I make is not really correct. Let me check. Okay, A, B, C. Already post in the group. Okay. So we take a break for 5 minutes. Okay. So if you want to go to the toilet. Little bit lagging. Now is okay? Is it okay now? Is it okay? Can you respond? Okay, okay. Okay. I already post the answer in the group. You can question D. You have to label this one the bracket. Okay, you have to label this one. Once you finish, you draw the cube. Oh, sorry. Why I use annotated? Once you draw the cube, you label. At the end, you have to label like this one. What is it? You have to label. At the tip of the arrow, right? At the tip of the arrow, one, three lah. This is you have to label. Okay, at the tip of the arrow. If the tip of the arrow is here, right? Okay. If the tip of the arrow here, so you have to label based on this direction indices. Okay. Okay. But this one is the opposite procedure from the previous slide. Okay, because we give you the direction indices, right? We give you the direction indices. You have to find where is the location. But if we give you the the number, okay, to convert it into the direction indices, okay, so you have to make it into integer. This one you have to find the location, you have to convert it into the divided by the integer, right? Okay, meaning that this one you have to divide by 3, divide by 3 by 3. So that the range is not more than 100. Okay, please make sure that one. Okay. Okay, so 5-minute breaks, and then we will move to the what is it? Miller indices. So we break. 5 minutes. 9:20 we will continue again. If you want to stretch your body, okay, so you can do. Okay, so let's we continue on the Miller indices. Share the slide. Here on the Miller indices. Okay, we will finish. Okay. So I hope that you can see this one clearly. Okay. For the Miller indices is actually is refer to the specific lattice planes of the atoms. So we have to calculate the planes. Direction indices is more to the coordinates or the the direction. Okay. But this one is more to plane, the list like area. Okay. So they are reciprocal of the directional intercept. The previous direction is reciprocal. That the plane makes is a crystallographic XYZ axis of the three non-parallel edge of the cubes. You look at here that once you define the position, right? This one, and this one, okay, just connect. So it's become a plane. But if for the direction indices, if you look at here, is from the origin towards that direction. Okay, is by arrow, right? Okay, but Miller indices is a plane. Okay, for the space lattice. Okay, this is the Miller indices 1, 1, and 1. Okay. Just as a crystal direction, different crystal plane have different characteristics and indices. So if you look at here that if your directions, if the position is 1, 0, 0, right? So meaning that if direction indices is just towards this direction, if direction indices, right? So for the Miller indices, okay, what you have to do, this one, this one, this one. Because 0, 0, 0 is become infinity. Towards Z direction is infinity, towards X direction is infinity. It is parallel with the X axis and also Y axis. Okay, so you have to remember. But this one is 1, 1, 0. When you divide it into this one, if you divide it into by 0, right? 1, this one, if you divide by 0, this is become infinity lah. Generally for 0 is become infinity. Okay, because you have to make it reciprocal. Okay, when you make it reciprocals, this one 1 divide by 1, 1 divide by 1, 0, 1 divide by 0. So meaning that 1 divide by 0 is a infinity lah, is an error. So meaning that for the Miller indices, 1 for the x-axis, right? Why is y-axis? But this one is infinity. 1 divided by 1 reciprocal, 1 divided by 1, 1 divided by 0 reciprocal, okay? Okay. So it's in parallel with the z-axis. So your nilai indices this plane. Okay, but this one is you make it reciprocal is 1, 1, 1. How about this one? 6, 3, 2, right? So meaning that 1 divided by 6, 1 divided by 2, 1 divided by 3, 1 divided by 3, 1 divided by 2. Okay. So this one, what if we divided into 2? So meaning that times with 2 lah. Times with 2, this one you can get 1 divided by 3, this one 2 divided by 3, and this one 1. So the position is 1 divided by 3, 1/3 is for x, 2/3, okay, for y-axis, and this one x-axis. So you just mark here, and mark here, and connect all the point. So you can get 6, 3, 2. But you have to do reciprocal first. Okay. So how to find the Miller indices? If you look at here, this is for the make sure plane does not pass through the origin. What do you mean by not pass through the origin? This one. This is not pass through the origin. We have this origin. This is the origin. This is the origin. Pass through is maybe like this. If you define this origin, it's pass through the origin. Okay. Determine the plane intercept at each axis. Intercept of each plane, meaning that this one, right? This one. This one intercept. This one intercept. This one is already parallel. Okay. Find the reciprocal of each intercept. Reciprocal 1 divided by that number. Okay, that particular number, the position. Okay, any fractions, clear fraction by multiplying by the integer. Okay, to determine the smallest set of the whole number. If not, please check is a negative or not. And then you have to make it parenthesis, okay, or bracket. We call it parenthesis. This one parenthesis. Okay. If there is negative, put a bar on top of the number. Okay. So this is the step. So what you have to do, if you look at here, that we know this one is already 1, right? This one is half, and this one is half. 3, 4. Okay, sorry. Half is here. 3, 4, right? Half x 1, 3, 3, 4. Okay, quarter. And then reciprocal. Step 2, reciprocal. 1 divided by half, 1 divided by 2, 1 divided by 3 divided by 4. Okay, so you can get 2, 1, 4 divided by 3. So make it integer 6, 3, 4. So you can make it. If this is if you want to find the Miller indices. If you want to find the intercept, so it's going to be opposite direction. If 6, 3, 4 is given, so you have to reciprocal also. Okay, so that you can get the smallest number, which is below than 100, not more than 100. Okay, meaning that is equal to 1 lah. This is the maximum for the cubic unit cell. Okay. Okay, so this is the step I highlight. Okay, so if you look at here, this is the example. The intercept is 1, 0, 0. Okay, so meaning that if you look at here, x equal to 1, right? X equal to 1. X equal to 1 here. But this one is no intercept, right? For y. So meaning that is infinity. This one also. No intercept is equal to infinity. So 1, infinity, infinity. Taking reciprocal, 1 divided by 1, 1 divided by infinity, 1 divided by infinity lah. So equal to 1, 0, 0. Okay, because infinity, 1 divided by infinity, of course, is 0. The Miller indices 1, 0, 0. So how about this one? So intercept is already stated here. 1/3, 2/3. Okay, then taking reciprocal, make it integer 6, 3. Okay. Okay, easy, right? Okay, so this one is determine the Miller indices of the planes that intersect of the following coordinates. if you look at here that negative 140, negative 1. Okay, this is 1, 140, 1, 1, 1, 2, 3, 4, 1, 1, 4, and all the coordinates. So x-axis is the intercept. If you look at here that negative half, negative 3, 4, and plus half. So if you taking reciprocal, negative 2, this one, and then clear fraction by multiplying 3, this one, right? Okay, so you can get the Miller indices. Okay. Okay, it's the same. If you want to draw the Miller indices, okay, if given the Miller indices, okay, it's stated that you have to draw the plane, right? You have to draw the plane. It's given 101. So you have to take the opposite. The procedure is going to be backward. Okay, so you have to same. We have to take reciprocal. Okay, 101. So it's going to be 1 infinity 1, and the intercept plane is this one, right? Y is going to be infinity. So if you look at here that, okay, this is infinity, right? Because if you mark here, first you mark here z equal to 1, x equal to 1. But is the infinity, right, towards this direction, parallel with the y-axis, right? So meaning that this one. Okay. Similarly, also for this one. Okay. So if you're taking reciprocal half, okay, should be, oh yes, 1 divided by 1, 1, 1. I see reciprocals, so half, you make mark here and then 1. So just connect all the point. Okay. Okay. All this this is another example. Okay. Sometimes we define a new origin because that we don't want to how to say, we doesn't want that the plane to cross the origin. Okay, that's why sometimes we define the new new origin. If you look at here is to the negative, right? Okay, so towards this direction. Yeah, because 1 negative 1 0 and 0 is infinity for z. Okay, but it's still this is the origin. Okay. Okay. Can you try this one? A. Okay, A, B, and C. Draw in unit cubic cells. Okay. For the following Miller indices. Okay. 1, negative 1, negative 1, 1, negative 2, negative 2, 3, 0, negative 2. Okay. I think you can draw in the Jamboard directly. And it wants to page 7. Go to page 7. Alamak. Saya tak bergerak pula Page 8 pula. Go to page 7. Okay. So please draw. Please draw. I give you 5 minutes or 10 minutes. I think it's just do number 1 and 2 lah. Okay. So you can. I will give you a tutorial. Don't worry. 1 and A and B. Only A and B. Because the what is it? This one the Jamboard is small. Cannot expand I think the template. So if you're taking reciprocal, 1 divided by 1, 1 divided by negative 1, 1 divided by negative, it's still same. 1 negative 1 negative 1. Yes, that is correct. That is on at the bottom, right? So where is the, so how you connect? X positive, so meaning out of the paper, out of the plane. Yes, it's correct. Yes, that one is correct. So make it shade. You can make it shade like that. Mungkin orang tak nampak sangat kan. So meaning that like this. Okay. Your plane is this one. Right. It's correct. Right. Sekarang. So this one for this one, also one for Z, one for Y. How about B? B is a positive, yeah, almost similar like A, only half because you're taking reciprocals. So meaning that the point is one, negative half, and negative one. Okay. Dah nak draw eh. So it's okay. Okay. So if for me, okay, you can draw. So actually from here also can make a point here. This one, and this one. Okay, we combine. The half is only which direction? Y direction, right? Okay. Okay, thank you. Yeah, that is correct. That is correct. That is correct. Okay. Okay. Good, good, good. See, for the, you have this one, right? Tutorial 7. Can you determine the Miller indices for A? This one, the pink. What is the Miller indices? A. Can you write down there? Can you write down? Okay. So 7. What is the Miller, the pink color? Pink shade. This one. A. What is the Miller indices? So there's the infinity there. So what you have to do is locate, determine the each point. Okay. And you have to make a reciprocal. Okay. So if you look at here, I just this one, right? I just define this one as the origin. Okay. So if you look at here, this is a 3 4. Okay. Okay, this one is like 3 4 3 4. So meaning that this one is 1 4. Okay. So point for this is a point for Z lah. Z, right? So meaning that it should be negative. There is a negative because I define this one as origin. So you can define also this one as origin actually. So no problem. Okay. And then y, if you look at here, that y towards that direction is equal to which direction? Uh, directions. X. X is point. Check. 0, 0. Oh, cannot. This one. This one is a cross. Cross the plane. See? So I just take this one as the origin. This one as a 0, 0, 0. Okay? So I cannot take this one because it's cross. See, if you make the what is it? Define this one as origin is going to cross the origin. So you cannot. So we choose this one. So meaning that still negative 1 4 for z. Okay. And then y direction on towards on the left side is going to be -1. Right, -1. Okay. Okay, I define this one. Because this one is cross like with the plane. So this one is 1 1 4. Z is a negative 1 4. Y towards the direction y is equal to -1. X towards this direction, right? Right. So x equal to infinity. Okay. So just taking reciprocal, if you look at here, that 1 divided by infinity, 1 divided by half, 1 divided by 1 4. So we can get negative 0, -1, and -4. So Miller indices is 0, 1, 1, 4 lah. Okay. So this is the Miller indices. Okay. Please be careful. Just now I define here is cross. I think if you define here also is possible. You define here because it's not cross the origin. Okay. Paham? Please make sure do not cross the origin. Like this one, this plane, the red color, right? Do not define your origin here. Please define here. Okay. This one is for C, I think. Okay, for C. Okay, do not define here because this is cross the origin. Okay, you can define here. Okay, the opposite. Okay. Any questions about the Miller indices? I'll give you just the answer. Right? Easy. Ada soalan tak? Any questions? I'll give you the answer for the Miller. If not correct, do let me know, okay? Sure. Just based on my okay. So for A, B, C, D, you can do that later. Okay, any questions? What's that? All clear. Okay. So just a practice. I hope that you can you. Generally is going to be different, but the what is it? Because you define your origin, so it doesn't matter. Still the same. Okay. Only the number lah. Okay, but the concept is still the same. Okay. The main concept is do not cross the origin. That's all. Okay. So wrong. Okay. Okay. So let's we next polymorphism. Last. Okay. Later I give you the tutorials and you can do. Hey, planar. Okay, sorry. Planar density and for 15 minutes. Okay, sorry. Okay, let's see the volume, planar, linear density, unit cells calculation. But this one is you have to understand. Okay, you have to master with the direction indices as well as the linear indices lah, especially planar and linear because planar is a Miller indices. You need the information from the planar Miller indices. While for the linear densities, you need the information from the uh, direction indices. Okay, so it's important. So okay, so if you look at here that for example for the volume density or volume, I think all of you already know, right? If for volumes density, meaning that is a density lah, rho. Okay, so generally we define we denote as a rho v lah. Okay, is equal to volume of the unit cell divided by vc lah. Okay, volume mass of the unit cell divided by the volume of the unit cells. Now, if we look at here that this is the atomic mass and this one is radius. So what we can determine is what we have to determine is the what is it? This one is the mass, right? And also the volume, right? So if you look at here that lattice constants to determine the volume, right? For the FCC, if you still remember FCC, how many atom per unit cell, right? Okay, you have to calculate lah. Okay, so the lattice constant is A. So we can get 0.361. Okay, and the volume of the unit cell is 4.7. This one, right? VC. FCC has 4 atoms per unit cell, right? FCC, you have to remember that. So mass of the unit cell, you have to calculate. How to calculate unit cell mass? 4 atoms times with this one, the atomic mass, and divide by 6.023. This is the Avogadro number. So you have to remember. Not remember exactly, you just know how to use it. So we can get 4.22 gram unit cell. So this one you divide it by the volume. Okay, 422 divided by 4.7. Okay, it's just a calculation of the density. So meaning that mass divided by the volume. Only how to calculate the volume and also the mass, you have to know. Okay, if you want to calculate, because there are 4 atoms times with the, what is it? The atomic number and divide by the Avogadro number. Okay, so this is how you calculate. So please remember, it's a change. It's different between FCC, BCC, and SCC. BCC, SC, and also FCC. It's going to be changed. Okay, and also the compound. Okay, the atom. Okay, what type of atoms? Okay, generally they didn't mention FCC. It just mention only the compound or the metals. Okay, so you have to determine, is it the metal is FCC or BCC. Okay, okay. So for the planar atomic density, if you look at here that planar atomic density is given 110, meaning that is a plane. Okay, this is the plane. How many atoms is crossed? Right, FCC and BCC, right? Because there is a body center of the cubic here. So meaning that it's become like this. So, all right, okay. So they have one full atom here. Here is cross one atom. This one is 1/4, right? 1/4, 1/4. Okay. And the lattice constant is 0.287. The lattice constant is A lah. This one. Okay. This one A. Okay. So meaning that equivalent number of atoms whose centers are intersect by a given plane. How many atoms? So if you look at here, it's crossed with one full atom here. One full atom. And 4 lah. 1, 2, 3, 4. If you look at here, this one, right? 4, right? Okay. So 4, 4, 1, 4, and one full atom. Because it is equivalent number of whose atoms whose centers are intersected by given plane. This is the plane. Okay. Area of the given plane, meaning that A times with the square root 2A lah. This is the area. Okay. So how to calculate? Plane intersect is equal to 5, because this one can be for the 1/4. If you combine, it can be 1 atom. This one is 1 atoms, meaning that 5 atoms. 5 atoms. Sorry, it's just a number of atoms. Okay, not the combinations. Meaning that this is considered as 1 atom, 1 atom, 1 atom, and 1 atom. Not like the previous one, right? Okay, for the FCC, how many number of atoms in the unit cells. This is only number of atoms who centered or intersected. Okay, so 5 lah, total is 5. It doesn't mean it's a 1, 4 or 1, 2. Okay. Equivalent number of atoms in 110 planes is equal to 2 atoms. Okay. Oh yes, 2 atoms. So area is a 2A. So look at here that 1, 2, 3, 4, 5. Okay. So total is 2 atoms. Okay. And divide by 0.287 lah. 17.2. Okay. For the linear, if you look at here that atomic diameter. Okay. So to half diameter, half equal to 1 diameter lah. So equal to full diameter. Okay, this is more to diameter. This is more to number of atoms lah, of 5. So this one is become full. So full 1 plus 1 is equal to 2. Okay, but this one is more to diameter, not number of atoms. This is the diameter of the atoms. Okay, so because this one is a R, right? This is R. This is 2R. Okay, and this one is R. So meaning that 2 diameters, 2 full diameters. Okay, length is this is just the length, not the area, because based on the direction indices, not the Miller indices. Okay, is linear. So meaning that 2 atoms divided by length. Length is equal to 4R. This one, 4R. Okay, the length is equal to square root 2A. Okay, that is for the linear density. So I think it's easy. Okay. Yes, last one before we stop density of the materials classes. If you look at here that the density is much greater for the metals compared to ceramic and polymer. So if you look at here, this is a type of the metals because it's close packing of the metallic bond. Okay, large atomic mass. This is all the compound or the atoms that which is a metals or alloy. Okay, and this one is the ceramic. Okay, let's see the setting is blue color, right? Less than packing, right? Okay, and then polymer. Okay, polymer like PTFE, silicon, PVC, right? PE, PET, all that polymer. And composite. Okay, composite is intermediate. Okay, it's just intermediate between ceramic and also polymer. Okay, and lacquer wood actually is content of the what is it? Crystalline and non-crystalline structure or morph structure, that is wood. Okay. Okay. This is a tutorial for the planar density and linear density. I think I'm going to put in the tutorials. Okay. For the assignment 3. Okay. Okay. This one also I will put in this one. Because I think that it's really not really, how to say, it's easy. Okay. So you can solve it. Tutorial 8. Okay, or you can do first. Next class we will discuss. Okay, you do first this one. Tutorial 8, 9, and 10. We will discuss on the next class. But just a very short. Similarly, also tutorial 11. Okay, tutorial 11. You can try first. Okay, later I give you the answer. Okay. Because we are almost done. Okay, we will discuss very short about the tutorial the density, atomic mass, and also planar atomic density. Okay, and then the definition of polymorphism or allotropy. Actually, metals can exist more than one crystalline form. It's depending on the, for example, like iron, right? If you heat it, okay, from negative 273 negative 73 negative to 900 and 134 1394 is become different. Okay, it's depending on the temperature. From the BC it can be formed as a FCC. Okay, this is based on the Gibbs phase rules. Okay, it can exist more than one crystalline form or structure. This is a polymorphism or allotropy. So this one, right, BCC, and this one FCC, BCC again, delta ion, gamma ion. Okay, and this is the examples. Okay, the carbon for the carbon polymorphism or allotropy. Okay, like a diamond, graphite, large fullerens. Okay, so this is the example. Okay, so atomic ready and also crystal structure. If you look at here is a difference between aluminium, cadmium. Right, aluminium is a FCC. Okay, like a simple, right? If we didn't mention the copper is FCC, just copper has atomic, so you should know copper is what type of the cubic cell. Okay, is this FCC or FCC? This one FCC, right? So let's say the question is a cobalt, and not cobalt, HCP. HCP is not, we not cover. Let's say it's chromium, so meaning that you have to know it's a BCC, and the atomic radius is this one. This is just how to say table for the radius or the atomic radius for the crystal structure. Okay, but HCP we not cover, like a titanium HCP, right? Cobalt HCP, cadmium is HCP, so we are not cover this one. Okay, any question for this part? Actually, the main content of this one is Miller indices, direction indices, atomic packing factor, planar density, okay, linear density, okay. This one is the main the main content of this topic. Okay, any question before we stop? Next week, we will move to we will discuss about the, what is it? I think it's more to like a defect, point defect. It's more to defect. No, you don't have to remember. Okay. Okay, so you need to remember operator such a no need to remember. Okay. How about the attendance? Okay, sorry. The attendance, right? Let me find the attendance. Stop the recording.